Hey, all right, so today we're going to look at how do we perform basic matrix operations. So we've performed operations with real numbers. Now we're going to do them with matrices. And matrices are really cool because you can use them to organize a ton of data. So first of all, what is a matrix? Well, a matrix is just a rectangular arrangement of numbers in rows and columns. Okay. So we call these the rows and these are the columns. So this matrix has 2 rows and 3 columns. Those are the dimensions of the matrix. The dimensions are read as rows by columns and they're represented with m by n. So we would say that this matrix is a 2 by 3 matrix. And finally, the elements are just the numbers inside the matrix. So this matrix has 6 different elements. All right, so let's try to state the dimensions of this matrix. So we know that it's read rows by columns. This has 2 rows, so this is a 2 by, and then 1, 2, 3, 4 columns. So this is a 2 by 4 matrix. And what element is in the second row and the third column? So I go to the second row, third column, that number would be 8. Okay, so now let's move on to actually performing operations with these things. First, we'll look at adding and subtracting matrices. Now, I know that this might look a little overwhelming, but if you really focus in on it, all it's doing is adding the corresponding elements. See how this is in the first row and first column, this A? Well, the E is also in the first row and first column of this second matrix. So our new matrix will just be A plus E, and the B plus F, C plus G, D plus H. And the same thing goes for subtraction, A minus E, and so on. Now we should take note that we can only add and subtract matrices that have the same dimensions. Like this is a 2 by 2 and a 2 by 2. 2 by 2, 2 by 2. If they didn't have the same dimensions, there would be no corresponding elements to add. You should also notice that the final dimensions of your matrix will be the same as the matrices that you started with. So if you add a 2 by 2 and a 2 by 2, you'll end with a 2 by 2 matrix. All right, so let's go ahead and try some of these out. Here we have 3, 0, negative 5, 1, plus negative 1, 4, 2, 0. So I know I'm going to end with a 2 by 2 matrix. And all I have to do is just add the corresponding elements. 3 plus negative 1 is 2. 0 plus 4 is 4. Negative 5 plus 2 is negative 3. And negative 1 plus 0 is negative 1. Subtraction is exactly the same. You just got to be careful to keep track of your signs. So here we would have 7 minus negative 2. So that's actually 7 plus 2. So 9. 4 minus 5 is negative 1. 0 minus 3 is negative 3. Negative 2 minus negative 10 is negative 2 plus 10, so 8. Negative 1 minus negative 3 is positive 2. And 6 minus 1 is 5. In the last example, whenever we go to add, we're missing a row here. So there's nothing to add to this 9 or negative 5. So because they're not the same dimensions, we cannot add. The next thing that we'll talk about is scalar multiplication. And it's like, what is a scalar? Well, oftentimes with matrices, a scalar is just a real number. Okay, so if you have a real number being multiplied by a matrix, all you have to do is multiply everything inside the matrix by the scalar. So here we would have negative 2 times 4 is negative 8. Negative 2 times negative 1 is 2, and so on. Negative 2 times 0 is 0. Negative 4, negative 14. All right, so let's try to put all of these skills to use to solve a matrix equation. Okay, so here we have a matrix equation, and we're going to solve it for x and y. We have this scalar 3 times these 2 matrices that are being added together. And notice this element has an x, and this element is a negative y. And all of this is equal to this matrix right over here. So we're going to start by adding these two matrices. So we still have a 3 being multiplied by these. And now we'll just add the corresponding elements. So here 5x plus 3, those are not like terms, so we have 5x plus 3. Negative 2 and 7 add up to 5. 6 and negative 5 make a positive 1. And negative 4 plus negative y is negative 4 minus y. All of this is equal to negative 21, 15, 3, and negative 24. All right, now we're going to multiply everything inside of this matrix by this scalar. Once I do that, I have 3 times 5x plus 3 is 15x plus 9. 3 times 5 is 15. 3 times 1 is 3. And negative 12 minus 3y. All of this is equal to negative 21, 15, 3, and negative 24. All right, now I'm trying to solve for x and y. But if we take a moment to notice some of the other elements in these matrices, we got 15 equals 15 and 3 equals 3. So I don't even have to pay attention to these things anymore. But that just let me know I was going in the right direction. So now I know that 15x plus 9 is equal to negative 21. And I also know that negative 12 minus 3y is equal to negative 24. And I can just solve each of these equations for x and y. 15x, subtract 9 from each side, gives me negative 30. So x equals negative 2. And here I can add 12 to both sides. Negative 3y equals negative 12. And y equals positive 4. All right, and that's how we perform basic matrix operations.